Press the recording, and thank you everyone for joining me for our virtual lunch and learn. I think this is our 16th one in the past few months, and it's been really exciting to work with all of you and help everybody with their education on drip and micro irrigation, as well as some other industry specific subjects that we've covered. So I'm Richard Rastuccia. I'm the Vice President of Water Management Solutions for Jane Irrigation. And we have a great presentation for you today, and it is on air vent training. Now, it's interesting because we've really done some presentations that started to get into designs of systems and what a good design looks like and what you should be doing to create a good design. And as we start building on our past knowledge, we get into a little bit more detail. So today, air vent training, a very specific detail of your system, a very important one, and one at which we have a real expert to talk about today. Cory Broad is doing our presentation today, and Cory is a certified crop advisor, he's a certified irrigation designer, and he's a certified ag irrigation specialist. But, and all those are admirable, but the thing I really appreciate about Cory, and this is, he said this to me before, and it's one thing that stuck with me, and that is he likes to work side by side with growers to really help them improve their businesses and their irrigation. And so when somebody gets an offer from somebody as talented as Cory to come out and get that help, you know, I certainly would be taking care of it or taking advantage of it, because Cory is definitely an expert in this area. So with that, I'm going to turn it over to Cory, and Cory, welcome.
Oh, thank you. I appreciate the kind words and introduction. And hopefully, you know, we can go through some stuff today. And for some of you, it may be a little bit of a review, hopefully, and then maybe some things in there as well that we can all learn and take away. And like I said, air vents are an important topic that I think get missed a lot in irrigation design, and is something that we can go through today, I think, pretty quickly, and also show you guys some good resources to look back on as well. So with that, we'll get started. And this is just kind of a roadmap of what we're going to cover today. We're going to look at different air vent applications, the different styles of air vents, and then we'll even work through an example of sizing an air vent. So getting into air vent applications, I pulled this first part of the slide from Irrigation, the 6th edition. It's a book that's published by the Irrigation Association, which is a great organization that I know many of us in our industry are involved in. Myself, especially involved in different committees and things like that as well. And that's where many of my designations have come from. And so this is a great resource. And so pulling it from that, the purpose of an air vent is to allow air to escape when filling pipelines, to allow air to enter when draining pipelines, to remove air pockets at system high points caused by entrained air, and then also help prevent suction inside your laterals after the system is shut down. And then below that, I took some common practices and tips. We'll go through some of these more in greater detail later. But basically, you want to always make sure you install an air vent at all high points in an irrigation system. So if you have elevation changes in your field, consider that. Your filter station, Richard and I talked about this earlier, here in the valley may actually be your high point in your irrigation system, as the top of those sand media tanks are several feet off the ground. And even if the field is flat, that is now your high point. And then also consider putting them at flush outs, which is a terminal end of your pipe. And then also consider installing them before and after valves. Doesn't matter if it's a manual valve or an automatic valve. That's a common practice you definitely want to participate in. And then roughly, you know, every 1,000 feet of pipeline, quarter mile at most, if it's just a straight pipeline, just helps continue to remove air as the water flows down that line. And then a thing that I think gets overlooked quite a bit is make sure that all air vents are clean, especially at the flush outs. That's a terminal end of your pipe where generally a lot of debris and material is going to accumulate over an irrigation season. And so you always want to kind of inspect those and make sure that they're working properly.
Hey, Cory, I just have a quick question about installing that air vent before the valve. Mm-hmm. What's the purpose of that?
So if that valve closes, so say you're running your irrigation system in 2 zones or multiple sets, And so take, for instance, you're running half of a field and then maybe another half of a field. And so when that valve closes down and you go to open up your other valve, that water is now hitting a trend just like it is at a flush out. And so to avoid water hammer or chatter, the best thing you can do is evacuate air in there and make sure you don't damage any components.
Yeah, that's great. That's very helpful. Thank you.
Yep. So this is a video that I took on a field call probably 2 years ago now. And the field call was, Cory, your air vents are leaking. And unfortunately, we get a few of those calls throughout the year, as I know many of our irrigation dealers probably do. But I'm going to click over next, and it's going to go into a video, and it might be a little bit loud, but I think it proves a very good point. So the purpose of that was a video live demonstration of exactly what an air vent is supposed to do. This was on a straight pipeline that was made to transport water between different pumping facilities. And the complaint was the air vent is leaking. Well, it's a continuous acting air vent, therefore it was continuously evacuating air in the system. So they felt like that the air vent was bad, and I said, no, it's actually doing exactly what it's designed to do. It's removing air. And sometimes, you know, especially when you have a lot of water in a pipeline, the only way to remove the air is to lose a little bit of water in the process. But a little bit of water on the ground is a lot better than air being locked inside your pipeline. That this particular one went several miles, which can reduce flow, cause water hammer, and a number of other issues. So that's just an example of some of the many calls we get.
Yeah. So it didn't matter how tight they made those fittings, or
no,
it's doing what it's supposed to.
Exactly. So,
yeah.
But exactly that is, here's a demonstration. So I kind of drew some stuff out. It's nothing that's any art by any stretch, but I think it illustrates a good point. So when you have your irrigation system off, especially after you've ran it at least once, there's always going to be water to some degree inside of your pipeline. And so at an off state and the air vent open to atmosphere, the pipeline is dominated by air, as you can see. As that system is turned on and is charging or filling, it begins to be dominated by water. And in theory, if your air vent is working and sized properly and it's open to atmosphere, it is now allowing that air to escape through that point. Eventually, once the system is charged, there will always be a little bit of air in your system, but hopefully you've gotten rid of a majority of the air, if not almost all of it. And so now it will be basically completely dominated by water, and then the air vent will seal and it will not leak. From there, when you turn off the system and you drain it down, the pipeline then begins to become dominated by air again. And that's because the air vent is now open back to atmosphere, and that's going to help break any vacuum potential that you have.
Yeah, so Cory, we have a couple of questions I think are appropriate to ask here. One, so if you don't have the air vent, what happens to that air?
That's a very big it depends. And things to consider is you have a pump, or even if in the landscape applications you're hooked up to, say, city water, and I know at my house I have 30 pounds of pressure. I know some people have significantly more than that even. You're talking about essentially compressing air.
Yeah.
Because the air is now being displaced by the water, and that pump or that pressure from your city line is going to compress that air into your pipeline, and that's where you can have water hammer and potential blowouts on, especially in fittings or 90-degree turns, even 45s. Water can also get locked inside fittings when it turns directions, and that can create an airlock situation and basically deadhead your pump, and it's still turning but water is not moving, and that can be a costly and or dangerous situation.
Right. So what's happening then is with the release of the air, if I've got this correctly, you're actually slowing the flow of water, not increasing it, right? Because one of our questions when somebody was asking now, does this speed the water velocity when you remove the air? And it actually doesn't, right?
Well, I mean, essentially your irrigation system should be designed with a particular water velocity in mind. I think while a valid question, it's probably just most important that the air is not there so that once that volume, because that pipeline was designed to handle a certain volume of water, and hopefully your pump is pumping exactly what you designed it to do. So in theory, you've accounted that entire area of that pipeline to be dedicated just to water. When you
Right.
have air inside of there, you're basically, putting, you're overfilling the garbage bag, if you will, and eventually that garbage bag's going to burst.
Yeah. Okay, great. Thank you, Cory. That helps.
Okay. So this is a cutaway demonstration of one of our air vents, our APV model air vent. And this is just kind of like I said, a cutout version. Are you able to see my cursor?
Just great. Yeah.
Perfect. So this particular air vent has a ball inside of a chamber. And what will happen is this threaded end of the air vent is connected to your pipe. And what will happen is as the water rises, it will eventually push this ball up and it will seal against this grommet. That is what will eventually lock this ball into place and not allow air or water to escape any longer. The idea is that this air vent is sized appropriately so that the airflow will pass by it and evacuate before the water fills up the pipeline and then seals it off. This is a look inside of one of those air vents. Taking the cap off, you can see that ball that's sitting down inside of there, and you can see these vent channels around it that allow the air to escape and go out the open orifice here at the top. Eventually, the water will come underneath this ball or float and will come up and will seal against this ring.
So is that ring plastic or is it rubber? Is there a rubber seal there or just plastic?
It's a rubber material. Helps ensure longevity and a good tight fit seal against this ball, which is made out of a plastic.
Yeah. Cool.
One of the points, again, to hammer home of why we're all here today is air vents are here to protect your investment. An air vent is designed to help you protect it in a number of different ways, but here's just an example of what eliminating air vents can do. And we'll show some examples of it, but breaking it down fiscally, if you take a 160-acre field, which is something that I'm common to working with, and it could be any specific commodity you want, but I know everybody's planting processing tomatoes right now, so maybe we focus on that. At a minimum, you could have $200 per acre in tape invested as a grower or as a business out there, and you may only have $25 per acre in cost per air vent to protect that, just that drip tape, not counting your pipelines, your valves, or any other material you have. So you're looking at an 8x ROI using air vents properly, and that doesn't include any potential yield loss if you have plugging or issues, as well as any labor to correct those issues.
That's a pretty inexpensive insurance policy right there.
Absolutely, all things considered. So that's a reason why, again, Jane is invested in this space and has so many different styles of air vents, is we want to make sure that we're able to protect all the other components that we sell on a daily basis and provide the best value to our growers.
Yeah. And Cory, we're going to get into how big or how to size these, right?
Yeah, we'll go through an example, and then also I'll show you guys some reference material that we have on our website as well to help.
Great, thank you.
So here's a particular example, and here is processing tomatoes. This is a field that I've looked at personally a couple years ago, and we got a call where the grower was complaining that the drip tape was being plugged. And so we went out and we took a look at it, and then this is what we saw. So I'll go into the details here in a moment, but when irrigation systems are turned off and water begins to drain out of the laterals, air is pulled into the system via emitters. Protection is needed to break suction and help reduce soil ingestion. So the reason I have this picture here is this actually isn't the tail end of the field. This is the end where the water is being fed from.
Hmm.
Usually when you see plugging in a field, it's usually at the end because it's an accumulation of debris or materials that haven't been flushed out. And this particular field was having plugging at the front end of the field. This is the tail end of exactly that same row. So significantly different. So that pointed me in a direction to say, okay, now I can go down a path to investigate what this is. And again, another example of illustrating this at an overhead view is you may have a pump down here in the corner and you're pushing water up, and then you come across this avenue and you have a valve here, and the system is all charged and flowing. When you turn off that system and water continues to flow downhill, even if it's what we identify as flat, standing in a field, there's always some type of fall in a field. And so what you can do is you can see right here at the head end of that field where the water was being pushed into the field via the valve, that suction can begin at that head end field, and you saw the damage that can occur over a season. Here's a particular dripper. It's fortunately not ours, but nonetheless, this was from that same field that was having that reduced growth or dieback. And so what we did is we went in and we looked at it, and the flow path, which is where generally most people would identify plugging to be, was actually very clear. And then we went ahead and we took the outlet and we pulled it back, and this is inside the outlet of the dripper. So that told us that the material was being pulled from the outside in, not going through the emitter and through the flow path.
So yeah, that wasn't just a little bit of soil. That was a pretty considerable accumulation. You could easily see why that would clog.
Yeah, absolutely. So, and especially once that depending on the type of soil that you have, once it dries out, it can become pretty tough to break up. And so even if you go back and you irrigate again and you continue to apply water, it may or may not be enough to get that material broken up and pushed out. And obviously in our case, it wasn't, when we were working with this grower looking at it, and there wasn't really a lot we could do.
Yeah. Wow.
So with all that, Jane in particular makes many different air vent styles. There are many offered to solve a number of different problems and offer solutions to growers and dealers. But just kind of going through some of the descriptions of them, there's an air relief valve, which allows air to escape until the pipeline or the check is sealed and water has filled. There's a vacuum relief, which prevents or reduces suction when the pipeline begins to drain. And then there are combination air vents, which combines the two previous styles together. And then there are continuous air vents. So earlier we saw that air vent that was burping water as the pipeline was running. That is a continuous air vent. It continuously allows water and air out of the system. And what makes that unique is, unlike the unit that we saw with the plastic ball that hits the seal, once it seals, it will no longer release any air or water. A continuous air vent has a secondary chamber that is much smaller than the initial chamber. And that's why you only saw a little bit of water leaking out of the top of those air vents, but you could hear all the air coming out at the same time.
Yeah, and that's the photo here on the left-hand side. That's the one in the middle. Is that right?
Yes, so this would be our ARV, continuous air vent. This is another one of our continuous air vents. And then these are our APVs, and then this would be our VBK. And we're going to go into each one of those in detail.
Excellent.
So our VBK air vent is economical. It's easy to clean. This little cap comes right off. You can unscrew it. You can check the seal. You can check the ball and make sure that everything is clean and clear. It is a dual acting air vent. It is an air and vacuum relief. It comes in 3/4 and 1 inch. And that is in reference to the thread size. And the clear and open diameter is 0.610 inches. We will get into why that is important in a little bit. Our APV air vent, again, is economical and easy to clean. This cap just as a quarter turn and comes off. It's dual acting as well. And it comes in 1 inch, 1.25 inches, 1.5 inches, and 2 inch. And its clear and open diameter ranges from 0.775 inches to 1.14 inches. ARV is a combination air vacuum and is also continuous. It is also easy to clean. This elbow up here at the top just threads right off and the main chamber is easily accessible. It comes in a 2-inch thread connection and its clear and open diameter is 1.29 inches. And looking at air vent placement, we talked about kind of some of those tips and tricks that I put in early on. This is actually from our air vent technical guide, which is available on our website. We'll go over that a little bit more, but this is just one piece of information that's readily available to all of our end users and dealers online and in our technical binders as well. And so this tells you kind of the best place to put different types of air vents. So air vacuum relief and then also continuous. And then again, you can see those boxes and it's a quick reference when you're maybe doing an irrigation design or a parts takeoff or even a walkthrough in your field, right? What type of air vent do I have? Oh, this is where it should be. And again, this is something that I see missed a lot where somebody may put an air vent before and after a valve, but maybe it's not the right type of air vent. So at least they were thinking about it, but just getting into the detail will help protect that product. So now we can kind of go into air vent sizing. So generally air vent sizing is based off of 2 factors: the size as far as the diameter and the length of a pipeline being protected, and then the clear and open diameter of the air vent, which is why I referenced that earlier. So I took some other material out of the irrigation 6th edition. And for this example, we're going to use 660 feet of 6-inch pipe, 6-inch diameter. A 6-inch diameter pipe has 0.179 cubic feet of air per foot of pipe per irrigation 6th edition. And so if you multiply that 0.197 by your footage, you realize that you need to get rid of 130 cubic feet of air. So now we can look, and this information is published in our catalog, at the 2 different APV style air vents. And again, referencing that clear and open diameter, 1.14 inches versus 0.775 inches, depending on the sizes, 1.5 inches and 2 inch versus 1 inch and 1.25 inches. 660 feet of pipe gives you your 130 cubic feet of air. A 1-inch APV will do 78 cubic feet per minute. Flow rate needed is 130. This vent's probably too small. A 2-inch APV will do 140 cubic feet per minute. The flow rate needed is 130. This air vent will suffice. And conveniently enough, in our technical brochure, as I keep referencing, if you look here, we help do some math for you to make it easy. A 6-inch nominal pipe diameter, cubic feet air release, 130. So without having to do all that math, we've helped make things a little bit easier for people as kind of a reference starting point. And again, there are always conditions that will affect these numbers, but this is definitely a good place to start. If you go and you have a very large pipeline and you're putting 1-inch air vents on it, this might give you some framework to adjust that.
That's great. I love having the math done for me. That's always appreciated. It's a lot less time for me. And then someone else was mentioning, oh, can you go back a couple slides? I just wanted to remind everybody that we will send the video of this to everybody so they can review. And of course, all this information is on our website as well.
Absolutely. It's there. And then obviously we have a dedicated team of professionals here, myself included. So we're always accessible in a number of different ways to help out our growers and our dealers. And so one of the key points too, in the air vent differences, not all air vents are created equal. Even though they may have the nominal sizes being the same, performances can vary greatly. You should check the flow curves. They should be published by manufacturers. The flatter the curve, the better. And I'll show you what that looks like. So if you look at APV air vents here, this is a very flat curve, all things considered. And so as you can see here, this is the air release and vacuum relief in cubic feet per minute. So the flatter it is, the more air you're moving with the less pressure differential required on that. And so in particular, if you go to one of my competitors' charts, you can see here they have a 2-inch air vent. It's extremely steep compared to something like that. And so somebody says, well, I just need a 2-inch air vent. Well, you better check the clear and open diameter, and you should definitely consider checking their technical brochures to make sure that their flow curves are going to be within spec of what you're trying to achieve. And then a quick list, again, just as somewhat of a review that I put together: air vents, do's and don'ts. You want to place them at terminal ends and flush outs, before and after valves. Use them at your filter station. Use them during elevation changes. And please check them periodically to ensure a working status. And then this is actually a call I went on this week, a few days ago. Do not place them before a booster pump or suction point. I had a grower complaining that his pump was cavitating, his booster pump. So I told him that I would go take a look at it. And within 2 minutes of arriving on site, I was able to identify that there was an air vent placed before the booster pump, which the booster pump was overpowering the pressure of the water that was in that line, pulling that ball down and then allowing air to entrain itself into the pipeline. And cavitation can cause significant damage to pumps and to fittings. And then please don't take them off because they're leaking. There's probably something stuck inside of them, and you probably have air in your system as well. So I've seen people say, man, that thing always leaks, so I just took it off and put a cap on. Please put them on. If your dealer put them in the field, they're probably there for a good reason. And then again, don't assume that all air vents, even the same size thread, perform the same. And please don't believe they are a waste of money. As we, I think, illustrated earlier, it can help you save a lot of money from a farming operation, or help save a lot of damage to your irrigation system. And then,
Cory, I have a couple questions here now before we go on to the brochures. And the first one is, how common in the ag world is it to see an air vent on a drip system?
It's very common. Probably, I mean, I would say they're on every irrigation system, I hope. But nonetheless, I have seen instances where maybe they weren't placed properly, or they weren't at terminal ends of flush outs. And that caused some issues with some emitter line in an orchard where it was pulling material back into the emitters when it was shut down. So there were air vents at the filter station, but then there were really maybe none in the field itself. So it's very common for us. There is kind of a joke in the industry that they're tractor magnets, because tractors tend to over. But nonetheless, there are a lot of them out there.
Yeah, so we have a question now, and I wanted to distinguish that, right? Because in the landscape world, you don't see them that often. And so somebody's asking, in a landscape setting, how important or beneficial are these air vents?
Yeah, I mean, I think that, again, we provide a number of solutions to fit different categories. We may be looking at, large volumes of air and water in our pipelines where, with the landscape space, it may not be the same. So maybe using something like a VBK air vent, which is a 3/4 inch thread, might be more acceptable. And I'd say that it's definitely there to help protect, because even the smallest pipelines always have air in them. And, it may not be $200 an acre worth of emission devices, but certainly the value of the products that we sell in our landscape market and that your team does needs to be protected.
Yeah, I agree. And that's what you mentioned is exactly what I have on my system at my home. And for anybody who's written a check to a commercial property owner or a property manager to replace a damaged landscape because of problems, you learn then how valuable those air vents are. And so, yeah, I like to recommend them on every system. It's just another piece of insurance. So anyway, thank you.
Absolutely. And to wrap all this up, there is a ton of resources, myself included, but right on our website, janesusa.com, there's our technical brochure for our air vents. So it has all that published information with the different flow charts, the thread sizes, clear and open diameters, working pressures, etc., all readily available right there at your fingertips. So if you're a grower or a dealer, there's a ton of information to help you make proper decision for that. And so again, in conclusion, air vents are necessary and inexpensive insurance policy for your irrigation system. Jane Irrigation offers a comprehensive line of air vents to meet the needs of many irrigation system types. And as always, we want to leave this world better than we found it, and we're here to help make more crop per drop.
Yeah, awesome, Cory. Great presentation. We're going to open it up for a few questions now too. But before we do, I just want to remind everybody that we will send out an email to all of you this afternoon with a copy of the recording, so you can review that, as well as Cory's contact information. So if you have questions that you think about later on that you want some help with, you can reach out to Cory and do that. So a couple more questions here, Cory, and that is, let's see, someone's saying that they're starting to use them in Riverside. And they're just saying, I'm sorry, it's more of a comment than a question. And they're saying it's definitely helping the situation there. And then do you think, somebody's got a question of whether or not this affects distribution uniformity or not? Have you seen any differences in that as a result of air vents?
Yeah, I think on newer systems, generally you won't see any impact, but much like we saw in that drip tape situation earlier, the distribution uniformity of that field was probably pretty poor because of all the soil ingestion that was going on. And so that particular system had been in the ground for several years. It was a thicker mill tape, so I think we were on like year 3 or year 4 of that system's performance. And so over that time, the DU definitely degraded, and that resulted in obvious crop loss and yield loss, which is, revenue for our end users.
Right. Okay, great. And then in areas where you do have hilly terrain, if you put these at the highest point, you'll get a significant difference?
I think it's definitely a big start. Every situation is going to be unique, just based on how the terrain falls. There's, ups and downs, and then there's, slopes and cliffs, and it really it depends, but it's always something to start. I know even particularly just for my small system at my home, putting an air vent helped reduce my valves from chattering on my landscape irrigation system. And so by getting rid of that air and eliminating that chattering of my valves, I'm probably going to increase the lifespan of the diaphragms inside of there.
Yeah, that's great. Now, Cory, this is a little bit of a takeaway from air vents, but you were on with a panel a few weeks ago talking about what's happening out there for growers in the Central Valley, and we've got a lot of them watching this afternoon. So wonder if you can just give us a little update as to what you're seeing out there. Is it business as usual, normal? What are the changes? Just a little dialogue on that, please. I think everybody would love to hear.
Yeah, absolutely. No, here in the Central Valley and in the ag sector in particular, we definitely have to do business as normal as much as possible. You look at commodities like almonds, grapes, pistachios, permanent crops. They've either were going to be planted or have already been planted. So that's going to require work. It's going to require fertilizer applications, your crop advisors walking your fields, irrigation. And so as much as possible, that is definitely business as usual. We're getting pretty far ahead as far as planting the processing tomato crop across the state. It usually starts in the southern San Joaquin Valley in the Kern County area and works its way north. And with most of, I'd say, the good weather we've had as far as from a planting perspective, not any real cold snaps and no major rain events, they've been able to plant a lot of those acres already. I'm already seeing cotton come up out of the ground, which is nice. So overall, from a day-to-day standpoint, it's very business as usual. And generally it's, we just got to keep farming. We can't really stop.
Yeah, that's great to hear. And everybody's staying safe too, right, is what I hear.
Yeah, absolutely. No, there's been, I'd say, some limited cases, given the population density of a place like Fresno and Fresno County. And I know all of my dealers and all of my growers have met with their teams and instituted measures to keep themselves safe, as well as the folks here at Jane Irrigation. So the business maybe doesn't do as much handshaking as it used to do, which is a big premise in the aggregation business. But nonetheless, everybody's staying safe, everybody's working hard, and it's been nice to, see ag shine in a time that's pretty hard for everybody.
Yeah, that handshake thing's really weird because, it's just such a normal thing to want to do, right? We've been doing it our whole lives. So
we always joke about the farmer wave. You got one hand on the steering wheel and you're going by the farmer waves. So I think that's where most guys are now.
Yeah, well, that's great. Well, listen, Cory, you were fantastic today. I've learned so much about air vents. Really appreciate that, and that's no surprise. Always learn great things from you whenever you're presenting. You have any final thoughts you want to leave everybody with?
No, I appreciate the kind words again and the opportunity to talk to everybody. And nonetheless, I'm always available. A lot of folks out there have my contact information directly. I know there's been some emails sent out from me for this particular event. So please reach out if you have questions. I'd be more than happy to consult with you, talk to you about it, and look for us on all of our different social media channels. I know you do a great job with that, and we're always available as a company to help you, achieve, again, more crop per drop.
Yeah, thanks, Cory. And yeah, take him up on it. It'll be a big help to you. So yeah, reach out to Cory. Again, everybody, thank you for joining us today. And we'll see you next week. I know on Wednesday, we've got a all-star homeowner association panel that we're going to be talking to about water management for a large homeowners association, several hundred acres where they're running up water bills in excess of $1 million a year. So what are they doing to save water and money in their association? We'll be talking about that next Wednesday. So hopefully we'll see you then. Thanks again, and we'll see you all here next week. Thank you.